part, the importance of mechanics in, the basics which are required for solving the numericals in the mechanics. So just we'll wait for 2 more minutes, let all of them join, and then we'll start the class. Yeah. Yeah, hi all of you. I hope you are able to hear me. Yes, just respond. If you are able to hear me, just respond. If you are able to hear me, just respond. Respond, all of you. Yeah, done. Right, that's good. 1 second. Yeah. Yes. I hope. Yeah. I hope I am clear. And I hope everyone have joined. Right. This is welcome to this today's session, all of you. And I want to introduce myself. This is Anupama, the physics lecturer, and today in this session we are going to learn about the basics parts of mechanics and how these mechanics parts are important in solving the numericals. Okay, so right, done. Thank you so much for responding. Yeah. Yes. Thank you all for responding. Yes, I just will start the session as everyone is here. Just give me a minute. Yes. Basic concepts of mechanics and the formula which are used in solving the problems. Do you know what are all the things we have in mechanics part? I think you all know mechanics plays a very important role and very important we have here the important chapters we have here where almost 40% of the question paper, 30 to 40% of the question paper consists of the mechanics problems only, right? So this in this session we are going to discuss miss as many as possible the formulas, the important concepts in solving the problems, right? We are not going to discuss about the numericals and all. It takes a little more time, but I will just try to cover the basic concepts which are used in solving the problems, right? Done. So now, what are the lessons we have in mechanics? The first lesson we start with is motion in a straight line, isn't it? So lesson by lesson we'll go. Motion in a straight line. This is the first lesson we have, right? Motion in a straight line is also called as kinematics, right? So, what are the things we are going to learn here in kinematics, especially? Kinematics is a part where we will learn about all those bodies which travels in straight line, maybe horizontal or maybe vertical. You all know the difference between the horizontal motion and vertical motion, isn't it, right? So, before we go for that, now I hope you all know the difference between distance and displacement, speed and velocity, and all that, right? So there are few scalars and there are few vectors, and I think you know the difference between scalars and vectors, right? Do you do you know the difference between scalars and vectors? Yeah. Scalars and vectors. Scalars are those which have no particular direction. Means usually you measure scalars only in terms of their magnitudes. Okay. And vectors are those which you measure both in magnitude and also in direction. Right. For example, if you take force, okay, or if you want to move a body from one place to another place, like I want to move a simple chair or table from one place to another place, okay, like you want to we want to move the body from one place to another place. How will you apply the force? You apply the force in the same direction. If I want to move this body in this direction, you need to apply force in the same direction, isn't it, right? Meaning, this is what means direction is very very important, isn't it? Direction is very important and direction plays an important role, right? Okay, so these are all the vector quantities. These are all the vector quantities. Exactly. Means why I'm telling is when we are measuring something, some physical quantity, when we are measuring, and when we take the direction into consideration, then obviously, that is termed to be a vector, right? So this is about scalars and vector quantities, right? So here in this lesson, why I told you is here in this lesson, especially, we are going to learn about uh, those physical quantities which are responsible for the motion of the body, like distance and displacement, speed and velocity, and all that, right? So I may not go in deep into it, but if you have any doubts regarding this, you can just ask me in the comment section. We will discuss that. 1 second. Are you able to hear me? Are you able to hear me? Acha, okay. You are able to hear me, right? Acha, done. Okay. Okay, fine. Okay, this is about scalars and vectors. And what are the physical quantities which are required for the motion of the body is the first one is displacement and distance. What is the difference between displacement and distance here? Displacement is nothing but the shortest distance, isn't it? Means displacement depends on only on final and the initial points. It doesn't depend upon okay. Final and the initial points, right? It doesn't depend upon the path traveled. Whereas um, Whereas distance is depends upon the path traveled, in which direction it is moving. Not exactly the direction, the total path, like whether it is a scale, whether it is a square or a circle or whatever it may be, it depends upon the path traveled, and accordingly we will measure the total length traveled by the body. That is about distance and displacement. And displacement is a vector quantity, and distance is a scalar quantity, right? And one more thing we have to remember here is distance cannot be zero, okay? Whereas displacement can be zero. Displacement can be, can be zero, right? So that is about, can be zero, can be negative also. Something is moving in the reverse direction, then displacement can be negative also, right? So this is about the distance and displacement. And next physical quantity we have is speed and velocity. Okay, speed and velocity. Speed is a scalar quantity and velocity is a vector quantity. Means velocity depends upon the direction, whereas speed depends upon doesn't depend upon any particular direction. Okay, speed depends upon the distance, and we can write speed as distance by time. Whereas velocity depends upon the displacement, and we can write it as displacement by time. Okay, what are the units of it? Centimeter per second, or we can also write this as meter per second. This is also same. Means both speed and velocity will have same units. Okay. So this is about the speed and velocity. But one more thing we have to remember here is whenever a body is moving for longer distances, in terms of kilometers and all, what happens is longer distances you can't measure in centimeters or meters. Like for example, a bus has traveled from one place to another area, another place, like another place nearby, then you can't measure them in meters or centimeters because it is longer distance. So longer distances usually are measured in kilometers per hour. So 1 kilometer per hour is equals to how many? How many meter per second? Can you tell me? Please respond. 1 kilometer per hour is equals to how many meter per second? Fast. Okay. 1 kilometer per hour is equals to 1 kilometer, how many meters? 1000 meters. By 1 hour, how many seconds? 3600 seconds. Okay. So, this will be, 2 200, two zeros, two zeros. No. Yeah, Hasini. This is 2 5s are 10, 2 18. So it will be 5 by 18 meter per second. Not thousand here. 1 kilometer per hour is equals to 5 by 18 meter per second. Okay. So this is about the conversion of kilometer per hour into meter per second. And this is longer distances we usually measure this. And as I told you, distance always will be positive. So speed also. So as the speed also will be positive always. Whereas when you take velocity, it depends on displacement, isn't it? Displacement can be zero or negative. So, and even positive also, right? Velocity also can be zero, negative, or positive. Okay. So this is about speed and velocity. And the next one we have here is right. Okay. Next one we have like types of speeds we have like average speed or velocity. Average speed or average velocity. Average speed or usually average speed is equals to the formula for average speed is equals to total distance by total time. Total distance by total time. Okay, so this is about average speed. And what about average velocity? We see one thing we have to remember here is whenever we take velocity into consideration, that will be displacement, and whenever we take speed into consideration, that will be distance. Okay, so this is the difference that you need to learn. Okay, I hope this is clear. Yeah. Yes. Yes, keep messaging, keep responding. If you have any doubts, you can ask here, and I am here to clear your doubts regarding not only this part. I'm just started discussing that, but in mechanics, whatever doubts you have, you just ask. We will discuss here. Okay? I hope this is clear. What Hasini? Both are same? No, distance and displacement are different. So definitely both will be different because one is depending upon distance and other one is depending on displacement. Isn't it right? So both will be different actually, not exactly the same. But when it comes to, tell Hasini. When it comes to the units, both have same units. Okay, Hasini, you can tell. Yeah, let Hasini type. Meanwhile, we'll just discuss about a simple thing. Yeah, for example, a body is moving from one place to another place. Sorry. Yes, yes. Who is this? Mulu Reddy. Yes, total displacement by total time, right? Like, for example, a body is moving from one place to another place, right? And then it has started moving half of the distance. Like, if, for example, total distance is x, okay, in that half of the distance, it started moving with v1 velocity, and another half of the distance, it started moving with v2 velocity. Now, how do you find out average speed or average velocity for this? Okay, we have formula total distance by total time. So I can write total distance by total time is x1 by x2 by t1 plus t2. x1 plus x2 by what, Hasini? Let 1 second. Give me some time. Okay. Let me complete this. Right. X1 plus X2 by T1 plus T2. Right. So now how will you find out this? Yeah. X1 is what? X by 2. Isn't it? Plus another X2 is what? Again X by 2 by T1. He didn't give T1 in the problem. So, but he gave velocity. How will you find out time from velocity? We have velocity is displacement by time. Isn't it? Time is equals to what? Displacement by velocity. So, displacement I can write as X by 2. By velocity is V1 plus again X by 2 by velocity is V2. Isn't it right? Yeah. Now X by 2 plus X by 2 is X by this X by 2 I can take common. You will get 1 by V1 plus 1 by V2. If you solve this completely, X gets cancels actually, and then you get 2V1 V2 by V1 plus V2. This is the formula you get after solving this. This is the formula for average velocity. Means in such situations, you will get average velocity like this. Now, for example, body is traveling from one place to another place in three different things, like 1/3, 1/3, 1/3. It has divided V1, V2, V3. Then how will you find out average velocity or average speed? See, one thing, both are same, but the thing is, both are same, but the thing is, here you get, 3V1, V2, V3 by V1, V2 plus V2, V3 plus V3, V4. Sorry, V3, V1. Okay, so this is how it will be, right? I hope this is clear. So this is how we find out average velocity. And next one we have is instantaneous velocity. Instantaneous velocity. Instant means at that particular instant, at that particular time. Instantaneous velocity is given by v is equals to dx by dt. You know what is dx by dt? Differentiation. I hope you know this, isn't it? I hope you know this. I mean, differentiation part, right? Isn't it? So v is equals to dx by dt. I mean, like at instantaneous velocity, you don't know. Ahmad, you don't know differentiation. Like for example, differentiation is nothing but dividing into the smaller things. Like for example, if the bigger part is there, for example x, and if I divide this bigger part to the smaller one, then this will be dx. Okay, so we will differentiate anything, like if it is the function of time, means with respect to time we are differentiating. If this is the function of time, then we'll differentiate a displacement, and if you differentiate displacement with respect to time, then you get velocity. Okay, so this is called as instantaneous velocity, means velocity at a particular instant, at a particular time. This is about instantaneous velocity. Okay, right? So, right. I hope this part is clear. And next we have is acceleration. You know what is acceleration? Acceleration is represented by A, and this is rate of change of velocity. V minus u by t. This is called as acceleration. V minus u by t. Right? What is v minus u? Units of velocity is meter per second, by units of time is second. So this will be meter per second square, or you can also write this as centimeter per second square also. Yeah, Hasini. Rate of change of velocity is acceleration, right? For example, a body is moving from rest. Means it is at rest initially, and from rest it has started moving, right? Then its initial velocity is zero. Initial velocity is represented by u, and its initial velocity is zero, right? And yeah, and for example, if the body has reached to rest, meaning what? Like for example, a vehicle is moving and we are applying brakes on the vehicle, then immediate the vehicle, what happens, slowly it comes down to rest, isn't it, right? So if it has come to rest finally, then its final position, final moment, velocity is equals to zero. This is initial velocity and this is final velocity, right? So this is about acceleration. Okay, acceleration is always positive. We experience instantaneous velocity everywhere. Like for example, I'll tell you an example. A body is moving from one place to another place, right? And yeah, and it is a vehicle, for example, it has traveled 3 kilometers distance, and for traveling 3 kilometers distance, uh, it took 15 minutes, right? For traveling, or 5 minutes or 15 minutes, whatever, right? I want to find out its velocity when it is at 2 kilometers distance. Okay, so 2 kilometers distance, it has taken, for example, 5 minutes. Then what will be the velocity at this particular moment? 2 by 5, no? 2 by 5 kilometers per minute. Like that means at that particular instant, at that particular distance, if you want to find out instantaneous velocity, that becomes the instantaneous velocity. Instant meaning moment, that particular moment, right? So we experience it every time, like when you have to find out your anything, any body's velocity, when it is traveling at a particular time or at a particular distance, then it becomes instantaneous velocity. Understood? I hope this is clear. I think so. Yeah, we were discussing about acceleration, right? So, acceleration, yeah, Hasini, yes. Acceleration will be positive when velocity increases. Means velocity starts from zero and slowly it increases, it will be positive acceleration. But when velocity slowly comes down to zero, it will be negative acceleration, and that negative acceleration is called as retardation. Okay? No, that's what I'm telling, Hasini. Negative acceleration will also be there. Negative acceleration is called as retardation. Okay? Positive will be there, negative also will be there. And acceleration may be zero also. When acceleration will be zero, I'll tell you what is the formula for acceleration. We have A is equals to V minus U by T. Isn't it? This is the formula for acceleration. Isn't it, right? Now, for example, for example, uh, velocity is velocity is positive, and this is zero, then it will be v by t. Initial velocity, if it is starting from rest, it will be v by t, right? If v is zero, then it will be minus this, if u is equal to zero, and if v is zero, this will be minus u by t. Minus u by t, this will be negative. Okay, Hasini, this will be negative when v is 0. From the formula you see. And this will be positive when u is 0. Right? What happens if a body is traveling with equal velocity? Means at every point the body's velocity is same. Then what happens at that point? If v and u are same, what happens? Can you tell me? I want the answers. Respond. If v and u are same, what happens to the acceleration? Respond. V and very good. 0. Yes. Yes, Prakash. V and acceleration. Karthik Mudiraj. Yes, it is correct. When V and not infinity. 0 by something will be 0, right? Isn't it? It will be 0. Huh. Right. So 0 by something is 0, so it will be 0. So acceleration can also be 0. That's what I'm going to tell. Hasini said, or is it always positive, you asked, isn't it, right? It's not always positive, Hasini. It may be negative, it may be positive also, and it may be 0 also, right? So when v minus u is equals to always same, change in the velocity is same, for example, then acceleration will also be same. Means when the difference in v minus u, for example, I'll tell you an example. A body is traveling from one place to another place. Its initial velocity, this is v1, and here it is v2, and here it is v3, and here it is v4, for example. Okay, and this is 2 meter per second here, and it is 4 meter per second here, and it is 6 meter per second here, and it is 8 meter per second. What is the difference in between this part and this part? v2 minus v1 is what? In equal intervals of time. That is very important. 2 seconds, 2 seconds, 2 seconds, and 2 seconds, right? Then what happens? v2 minus v1 is 2. Again here also this part, this interval of time also 6 minus 4 it is 2. And 8 minus 6 it is 2. Means v minus u is always same. That means acceleration is always same. So when acceleration is same, this particular thing is also called as uniform motion. We call it as uniform motion. The body is said to be with uniform acceleration or uniform motion, right? So this is about uniform acceleration or uniform motion. Okay? Fine. I hope this part of acceleration is clear to everyone. Now we will go to the equations of motion. How many equations of motion you have learned? Can anyone tell me? Body moves with zero acceleration. Means it is, if body is moving with zero acceleration, then it is moving with equal velocity. Velocity will be same. Isn't it? It is not accelerating. When the body is said to be accelerating, when like body is moving with different velocities. When body is moving with same velocity, then definitely it will have zero acceleration. Zero acceleration meaning body is moving with same velocity at every part of the time or every part of the instant, the body is having same velocity. Okay, uniform motion only. That also fine. I hope this is clear. Ha, exactly, Karthik. That's what I'm going to tell you. Yes, yes, yeah. How many equations of motion you have learned, Karthik? Karthik, you wrote few here, one here. Just tell me how many equations of motion we have learned. Very good. Only three, Karthik, but I think there are four. There are four. Can anyone write here the three equations of motion you have learned? Karthik wrote one, but that is not correct, Karthik. That should be yes. Yes is not V. V. Hasini, that is not V. That is yes. Yes is equals to ut plus half AD square. Yes, Shaikh, that is 4. Can anyone write at least another one? One is over here. Hasini, yes. Write down the equations. Write down the equations. Whatever you know. Exactly. Yes, Zareen, correct. Karthik, V square minus U square is yes, correct, absolutely. Fatima, yes, correct. And the fourth one, anyone? Three I got here. The fourth one I want. No, Hasini, that is over. The first one is V is equals to U plus AT. Yes. Second one is what? Shaik? 2A is over. Apart from this, I'll tell you. This is the distance traveled by the body in nth second. Nth second. Exactly. Who wrote this? Prakash. Very good. Janvi, yes. Sn is equals to U plus A by 2 into 2n minus 1. Yeah, Prakash. Yes. Okay. So this is about equations of motion, right? The four equations of motion. And what is common among all the four? Can anyone tell me? Have you noticed what is common? Anyways, you have learned all this. Just tell me what is common among all this. All the four equations of motion. Fast, fast. I want answers fast. What is common among all the four? Oh, common thing you find out among all the four is acceleration, isn't it? Among all the four equations of motion, acceleration is common here, isn't it, right? Means all these equations of motion are applied under uniform acceleration. Yes, yes, Sirisha. Very good. Janvi, yes. Yeah, Zareen, yes, acceleration. The common among all these is acceleration, right? So this is about equations of motion. and this is what you will learn in horizontal motion. Till now whatever you have learned is about horizontal motion. Before we go for the vertical motion, we'll just discuss about the very important graphs which are applied here. Yeah, yes, all of you are right. You have come up with good answer, correct answer, that is acceleration. Now we will discuss about graphs before we go for the vertical motion. Okay? Yes. Right. First graph is a displacement time graph. You can also call this as ST graph. One thing we have to remember here is if there is any time taken in the graph, means for example, you want to show the variation of any physical quantity with respect to time through a graph, then time is always taken on x-axis. Okay, and the second one is taken on y-axis. Okay, right. For example, I will draw a diagram like this. You all know, I need not tell you, this is x and y-axis, right? Along x-axis, as I told you, always time will be there, and this is the displacement. Now I am drawing a line which is parallel to x-axis, that is time. What do you mean by this graph? What does this graph tells us? Tell me, what does this graph tells us? Like, I'll give you a hint, okay? In this graph, if you see, x-axis is varying whereas y-axis is not changing. That means time is changing but displacement is not changing. What does that mean? What does that mean? Fast. What constant, Sabah Fatima? What is constant? Velocity. This is a displacement time graph. Not vertical exactly. Constant velocity? No. We are not discussing about velocity as such. What, Shaikh? Velocity? No, I'll tell you what. I'll tell you. There's no velocity here. We are not discussing about velocity. I'll tell you what when velocity comes. No. Shaikh, wait. I'll tell you. Here, time is changing, but displacement is not changing. Like, for example, I have a pen here with me. Okay, I am placing the pen here itself on the table. I'm going out. Again, coming back after an hour or 2 hours. The pen is still here. What does that mean? Pen is not moving. Isn't it right? What does that mean? That means that the body is said to be at rest. Okay, because it is not moving with respect to the surroundings. Isn't it right? So the body is said to be at rest. Means after 1 hour or after 2 hours, right? It is not changing its position. Isn't it? So this means this particular diagram or graph tells us that displacement is 0 or distance is 0. This means it is set, the body is said to be at rest. Exactly, Hasini. That means the body is said to be at rest. There's no change in the displacement or there's no change in the position. The body is said to be at rest, right? So this is about displacement time graph. Okay, another graph, same displacement time graph only. If I draw like this, what does this mean? Yes. Tell me, what does this mean? Fast. No one? Shall I tell? This means that S is directly proportional to T. That means T is increasing, S is also increasing. T decreases, S decreases equally. That means that this is of uniform velocity. Body is moving, S, and it is of uniform velocity. Okay? Positive straight line. Good. Who wrote this? Janvi. Oh. Yeah, uniform velocity, not uniform displacement. It is said to be uniform velocity. Okay? So this is about displacement time graph, and it depends. Like it depends on the shape. If it is negative, it is coming down. Like you can take another graph also, which is starting and coming down here, going into negative, isn't it? This also you can draw, or if this also you can draw like a curve which is not, which tells us that it is non-uniform velocity, right? So all these you can give, you can tell the motion of the body by using simple graphs. Okay, done. So next one is velocity time graph. I hope that displacement time graph is clear. You was correct, Sheikh. Okay, I didn't see this. I think I missed your message. Uniform velocity you wrote. Yes, yes, right. Yeah, I missed that. So this is velocity time graph. Okay? Huh. Velocity time graph. This is on x-axis. Time, as I told you, right? Time always on x-axis and velocity on y-axis. Right? Again, I draw the same diagram. I mean, same line which is parallel to this. Can anyone tell me what is this mean now? Sheikh, try. Now Sheikh will try. Prakash, are you there? You can try. Hasini, try fast, fast, fast. Time is up. That line tells us that V is not changing, isn't it? That is parallel to x-axis. That means the physical quantity on x-axis is changing, whereas the physical quantity on y-axis is not changing. That means velocity is same. Exactly, Hasani. Yes. Not exactly zero, but that is same. V is same, not zero. Exactly. Constant velocity, Sheikh. Good. Right. I'll draw one more now. Zero acceleration. Good. Who said this? Prakash. Wow. Prakash, try. Try this. What does this mean? Sheikh said constant velocity. Very good. No, 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 no. V is constant. Uniform acceleration. Karthik, very good. Uniform acceleration. Yes. That is, A is constant. Yes, Bhavani, correct. Karthik, correct. Yeah, Hasini. Yes, all of you are correct. Very good. Prakash has come out with the perfect answer, and his answer is first actually. He came out first. Fine. This is about thing. One more thing we have to remember. I'll just go back. Right? I'll just go back and say, like, see, here what happens is, I mean, this is displacement time graph. Yes, yes, all of you are correct. Fine. This is displacement time graph and area under displacement time graph. Like you need to find out the area, for example. Like area under displacement time graph will give you what? Area is length into breadth, isn't it, right? I mean, area you leave it. Slope, for example. Slope. What is the formula for slope? Slope is equals to displacement by time. Isn't it? Because y by x, no? Slope. Displacement by time, which is nothing but velocity. Meaning, slope of displacement time graph will give you velocity. And slope of velocity time graph will give you acceleration. Acceleration. Slope of velocity time graph will give you acceleration, isn't it? That is, acceleration is equals to v by t. Formula. You know this, right? So, v is, here slope is nothing but v by t only, no? Y by x. Y-axis, what do you measure? V. X-axis, time. So, slope of velocity time graph will give you acceleration. And what about the area under velocity time graph? Yes. Yes, Hasini. Area under velocity time graph. This is, for example, there is something like this, and this is velocity time graph, and you need to find out the area. Area is equals to, what is the formula? If it is a perfect rectangle, then it is length into breadth, or a square, it is length into breadth. Length from the graph, you will get velocity, into breadth from the graph, you will get time. Isn't it? Means along length, it is velocity, y-axis, no? Breadth, it is time. So velocity into time is nothing but acceleration. Sorry, displacement. Yeah, displacement. Because velocity is displacement by time. Displacement is velocity into time. Exactly. Yes, Hasini. Okay. So this is about velocity time graph. Next we will discuss about acceleration time graph. Acceleration time graph. Okay. Now, the area under acceleration, you can't take the slope actually, but area under acceleration time graph. For example, tell me, area is equals to length into breadth is equals to, along length, what you will get? Along length is acceleration, along the breadth it is time. Acceleration into time, can anyone tell me? Acceleration into time. No, acceleration into time. Velocity, exactly. Who is this? Sheikh Muzyuddin. Yes, yes. Velocity. Acceleration into time is velocity. Velocity. Yes, Sirisha. Good, good, good. Hasini, good. Fatima. Yeah, yeah. Good. Yes. So how? Because acceleration is velocity by time. If this time comes this side, it will be velocity is equals to acceleration into time. Isn't it right? Yeah. So area under acceleration time graph will give you what? Area under acceleration time graph will give you what? Velocity. Yes. Okay. So this is about graphs and this is all about horizontal motion. Okay, horizontal motion. Till now, whatever we have discussed is all about horizontal motion. But in motion in a straight line, we also have vertical motion, right? And also we have work, power, and energy and Newton's laws, which are actually very important. That we will discuss. Continue in the next class. I hope this class is clear for you, and if you have any doubts regarding this, you can just ask me now. We will discuss more. We have 2 or 3 minutes time. Just tell me if you have any doubts on this. We will discuss. I hope everything is clear. Yes. Yeah. Hope everything is clear. Or you have any doubts regarding this session, you can just post it fast. Is it clear? Yeah. Please respond. We'll wind up. Yes. Exactly. Hope this session is useful for you and clear. We will continue in tomorrow's class. And one more important thing, if you have any doubts from today's session or any session, anything, any chapter, you please make a note in your notebooks and you can ask me tomorrow, right? Hope this is clear for you all. Have a nice day and we'll see tomorrow. What has any displacement time graph? Huh? Yeah, thank you all of you. Thank you so much. Yes, slope again we'll discuss it